Okay, students, let's get started today with a discussion of ATP design questions. These are usually your question number fours and they carry 6 marks. Before starting the discussion on question number four, I would like to discuss three types of variables: independent variables, independent variables, dependent variables, and control variables. And control variables. What are independent variables? Independent variables are the variables that you vary, that you or the person conducting the experiment varies in an experiment. In an experiment. Independent variables are those variables which you vary in an experiment. You can write this completely here. Independent variables. Perfect. Independent variables are the variables that you vary in an experiment. Okay, what are dependent variables? What are dependent variables? Variables that vary or change, that vary or change due to the change in dependent variable. Whenever you change the independent variable, the variable that changes as a result is known as your dependent variable. Simple. What are independent variables? The variables that you vary in an experiment. What are dependent variables? Variables that vary or change due to the change in independent variables. Let's repeat again. Independent variables are those variables which you change in an experiment. Dependent variables are those variables which vary or change due to the change in independent variables. What are control variables? Variables that are kept constant, variables that are kept constant throughout the experiment. Throughout the throughout the experiment. Now, let me show you an example. Let me show you an example question. Where do we have this? 1 second. Let me take you to the PDF for the example question. Yeah, let's read out this question. A student uses ice cubes to investigate the time taken for different masses of ice cube to melt when the ice cubes are placed in water. Perfect. Plan an experiment using ice cubes to investigate how the mass of ice affects the time taken for the ice to melt. Now, here, what will be your independent variable? What can you change? What can you vary in this experiment very easily? That is the mass of the ice cubes. Mass of the ice cubes, mass of ice cubes will be your independent variable. And what will be a dependent variable? As you change the mass of the ice cubes, the time taken for the ice cubes to melt will vary. So, time will be your dependent variable. Time will be your dependent variable. Simple. If you plan an experiment to see how different masses of ice cubes take different times to melt, your mass of ice cubes is your independent variable which you can change easily. Time is your dependent variable which changes as a result of you changing the mass of ice cubes. Let's do another example to solidify our concepts. This PDF is attached in the description below. Yeah, let's see this. Water is heated from room temperature to its boiling point in a glass beaker. Perfect. Plan an experiment to investigate the time taken for the water to reach its boiling point. Depends on the diameter of the water surface exposed to the air. Can you see here that we can easily vary the diameter of the water surface exposed to the air? So diameter of water surface will be what? Diameter of water surface will be your independent variable. Anything that you can vary easily in an experiment is your independent variable. Time taken for the water to reach its boiling point will be your dependent variable. Simple. Simple as that. If you change the diameter of the water surface, the time taken to reach the boiling point will change. Simple as that. One is independent, the other is dependent. Nothing complicated here. Now, let's see another example. Let me see here. No, this not this one. Yeah, let's see this. A student investigates the factor affecting the bend angle of a metal strip. The student places a thin straight metal strip on two supports and attaches a mass of weight W to the middle of the strip. Perfect. So this is a mass of weight W. Oh, let me highlight it like this. This is a mass of weight W. Perfect. The metal strip bends as shown in figure 4.1. Perfect. Plan an experiment to investigate one variable affecting this angle theta. So, what can we do? We can assume that we are attaching different masses here and we are measuring the consequent bend angle. So, what are we actually changing? What is the thing that you can easily change? Weight. Weight will be your independent variable. Weight will be your independent variable. Angle is your or theta is your dependent variable. Simple as that. Simple as that, dependent variable. Sorry for this wrong spelling. This is independent variable. Now I hope this is clear to you what are dependent and what are independent variables. Let's further move ahead. Now the third type of variable that we studied was control variable, or the variables that are kept constant throughout the experiment. Now, what are these variables? What are the control variables or the variables that we need to keep constant throughout the experiment? Now, here is a key point. Any variable, any variable that can affect, that can affect, please listen to this carefully. Any variable that can affect the dependent variable, any variable that can affect the dependent variable, and here you can write it in brackets, other than the independent variable, other than independent variable, other than independent variable, any variable that can affect the dependent variable other than the independent variable is the control variable. Now, I know from the looks of it, this seems a very, like you can say, difficult definition. But let's apply it. Let's apply it. This will become easier. Let's apply it to actual questions. Let's go to the first example that we did here. One second. Yeah, this example. Let's see this. Here, you had different masses of ice cubes and you were investigating the time taken for the ice cubes to melt. So, what is your dependent variable? Time taken for the ice cubes to melt. Is there any other factor that can influence the time taken for the ice to melt? Yes, is there any other factor that can influence the time taken for the ice to melt? Hmm. These ice cubes are placed in water. These ice cubes are placed in water. So your control variables can be what? Your control variables or your constant variables can be what? Time taken, or you can say your control variables can be what? The first control variable will be the volume of water. The volume of water. Now, what do I mean by volume of water? Let's say you are placing a 50 gram of ice cube in, let's say you are placing a 50 gram of ice cube in, let's say, 100 cm cube of water, and then let's say you are placing this 50 gram of ice cube in, let's say, 50 cm cube of water. Okay. Let's say you have two different beakers. One has 100 cm cube of water, the other has 50 cm cube of water. Both have a 50 grams of ice cube. Don't you think that the volume of water present will affect the time taken for the cube to melt? Yes, the volume of water present inside the beaker will affect the time taken for the ice cube to melt. So, this variable should be kept constant. Any variable that affects the dependent variable, that in this case is what? Time taken for the ice cube to melt, should be kept constant. Any variable that affects the dependent variable, that is the time taken for the ice to melt, must be kept constant in the experiment. Or you can say any variable that affects the dependent variable is your control variable. The volume of water is a control variable. Secondly, the initial temperature of water will also be a control variable. You want the initial temperature for the entire experiment to remain same. Initial temperature of water. Simple. So these are your control variables. These are your independent and dependent variable. This is also written in the marking scheme. Don't worry about answer writing. We haven't even started how to write the answer. We haven't even started writing the answer. Just sit back and relax. Listen for some time. So here you can see initial temperature is a control variable. Initial volume is a control variable, as you can see. Let's move ahead. Let's try this technique on the second question that we did. So in the second question that we did, we were varying the diameter of water surface and we were investigating the time taken for the water to reach its boiling point. Perfect. What could be your uh, what could be your control variables here? What could be your control variables here? Your control variables can be the volume of water that is used. Your control variable can be the initial volume of water that is used. Now, sir, what do you mean by that? This is your control variable. Why? What do I mean by that? Let's say, you have a beaker that has 50 cm cube of water, and then let's say you have a beaker that has 100 cm cube of water. Which beaker will take a larger time to reach boiling point? Obviously, the second beaker, which has a larger amount of water. So, water also affects the time taken for the volume of water, also affects the time taken for the water to reach boiling point. So, hence, initial volume of water will be your control variable. In this experiment, your initial volume of water will be your control variable. You can check this in the marking scheme as well. Volume of water. Mass of water is a control variable. The water should be initially at the same temperature and keep the Bunsen burner flame as constant. These are some control variables. You only have to write one or two control variables in the examination. We will discuss how to write the answer just in 1 minute. Now let's move on to how to write an answer in your design question. Now let's move on as to how will you write an answer in your design questions for ATP. If in your ATPs it is written briefly explain how to do the investigation. If in your ATPs it is written briefly explain how will you do the experiment. You will tell the examiner how will you measure the independent variable. You will tell the examiner how will you measure the dependent variable. And you will give the examiner an overview of the entire experiment. Lastly, you will tell the examiner to repeat the experiment for different independent variables. Perfect. If in the design experiment it is written to list down any additional apparatus that is needed, you will list down any apparatus that is needed to measure the independent and dependent variables. If you have to state the variables that need to be kept constant, you will mention the control variables. We have discussed what are control variables. And if in the examination you are asked to draw a table with column headings, you will do what? You will display the quantity slash unit. Quantity slash unit. Let's say you were measuring the mass of ice cube. So mass slash unit. And the time for it to melt. Time slash seconds. However, if in the question you are provided with symbols, let's say the examiner has told you that mass is equals to m and time is equals to t, you can replace the quantities by simple symbols m and t. Simple, nothing complicated. Lastly, in the design questions, the examiner will ask you to tell how these readings are used to reach a conclusion. But whenever in examination you are asked that how will you use these readings to reach a conclusion, what will you say? You will say compare the readings of the independent variable with the dependent variable and see if the independent variable affects the dependent variable. Or there is another method as well. You can say plot a graph of independent variable on the x-axis and dependent variable on the y-axis. Secondly, if you are asked to draw a diagram of the apparatus, you can draw a diagram with all the missing apparatus, and if you need to specify any quantities, you can specify that as well. Let's look at an actual exam question. Let's look at an actual exam question and let's write an answer. So let's see, let's look at this question. Water is heated from room temperature to its boiling point in a glass beaker. Plan an experiment to investigate the time taken for the water to reach its boiling point. Depends on the diameter of the water surface exposed to the air. Perfect. So here I know some of the things. First of all, here I know that my independent variable is what? Mass of the ice cube. Dependent variable is what? Diameter of the water surface. Okay. And control variable is the initial volume of the water. Simple as that, nothing complicated. You are provided with a supply of cold water, a set of glass beakers with different sizes, a Bunsen burner, tripod, and a gauze, a measuring cylinder. Perfect. You may use any other common laboratory apparatus in your plan, include any other apparatus that you need. Okay, so you have to tell any other additional apparatuses that you need. Perfect. Any other additional apparatus that you need. And if you notice here, you don't have a stopwatch. Your dependent variable is what? Your dependent variable is time. Your dependent variable is time, but in the list of apparatus, you don't have a stopwatch. So you will need a stopwatch to measure the time. Perfect. Secondly, to measure the diameter of the glass beakers, you don't have anything to measure the length. So you also need a vernier caliper and a meter rule if the diameters are too big. So the additional apparatus has quite a long list. Vernier calipers. We will write the answer. Don't worry about it. Vernier calipers, stopwatches, and meter rule. And meter rule. Perfect. Let's see point number 2 what the examiner is asking. We are just marking things. We haven't started writing the answer. A brief description of the method and how will you make sure your measurements are accurate. So here you will have to tell what is the independent variable, what is the dependent variable, and how will you carry out the experiment. In the third pointer, you have to tell about the control variables. In the fourth point, you have to tell about the table. In the fifth point, you have to draw a conclusion. For drawing a conclusion, I have told you two methods. So let's start writing the question. First of all, you will say the additional apparatus, or you can say, we will need a stopwatch, a stopwatch to measure the time taken for ice to melt. Additionally, additionally, oh, I have put in this wrong. Additionally, we will also require a meter rule, a meter rule, and vernier calipers to measure the diameter of glass beakers, to measure the diameter of glass beakers. Now this caters the first point. Your first point is done. I will keep on placing a tick here. Your first point is done. Let's move on to the second point. A brief description of the method, including what you will measure, that is the independent and dependent variables, and how will you make sure your measurements are accurate. Perfect. So you will say measure, measure a known volume, a known volume of water, let's say 250 cm cube, 250 cm cube, using measuring cylinder. Measure a known volume of water, let's say 250 cm cube, using measuring cylinder, and add it to the glass beaker. And add it to the glass beaker. Simple. Add it to the glass beaker. Simple. What will you do next? What will you do next? Yes. What will you do next? Yes, beta. Any ideas? What will you do next? Okay, make a correction here. This is, we will need a stopwatch to measure the time taken for the water to reach its boiling point. Water to reach its boiling point. Because this is the boiling experiment, not the ice cube wala experiment. So we will need a stopwatch to measure the time taken for water to boil. Simple. Additionally, we will also require a meter rule and vernier caliper to measure the diameter of glass beakers, measure a known volume of water to 50 cm cube using measuring cylinder, and add it to the glass beaker. Perfect. And you will say start heating the water, start heating the water, and measure the temperature using thermometer. So thermometer is also an additional apparatus that you require. Thermometer is also an additional apparatus that you require here, because thermometer is not given here. Perfect. What will you further say? What will you further say? What will you further say? Stop the stopwatch. Stop the stopwatch when the thermometer when the thermometer starts showing showing a constant reading, a constant reading. Stop the thermometer when the stop the stopwatch when the thermometer shows a constant reading. Because when the thermometer starts showing a constant reading, that means you have reached the boiling point. Simple. So this is the crux of your experiment. This caters a brief description of the method. Now, what will you say? What will you say? Repeat the experiment. repeat the experiment for different values of repeat the experiment for different values, or you can say different diameters of glass beaker. Repeat the experiment for different diameters of glass beaker. Simple as that, nothing complicated. Okay, this caters your second point. You have completely catered the second point. What are the variables that you will control? The volume of the water, initial volume of the water, which is 250 cm cube. You make sure that this 250 cm cube of water remains constant throughout. Initial volume of water will remain constant, the mass of water will remain constant. You can write these control variables. Uh, the initial the initial volume of water, the initial volume and mass, you can say it like that. The initial volume and mass of water is the control variable. Simple as that. The third point gets catered out. Perfect. What is the fourth point? You have to draw a table for the results. So, whenever you are drawing the table, I have told you one simple thing. Just write the quantity slash the units. What is the quantity here? Diameter slash the units, let's say in centimeters or in meters. Diameters slash, you can say centimeters, and you can also write meters here, you can also write millimeters here, depends. Time slash seconds, but you have to make a table like this. Fourth point gets catered out. The last point, how will how you will process your results to draw a conclusion. So you can write 2 points here, you can write 2 points here, whatever suits you. How will you draw a conclusion with your results? You will say, compare compare the reading of diameter compare the reading of diameters with the time time taken to reach boiling point, with the time taken to reach boiling point. See or observe if there is a relationship. Observe if there is a relationship or a trend, or you can say compare the readings of diameter with the time taken to reach the boiling point and see whether they affect each other or not. See whether they affect each other or not. If you want to finish your answer here, you will be getting a 6 on 6. No questions in that. You will get a 6 on 6 here. But if you are really aiming for that distinction, or if you are really aiming for that A star, you can write one additional point here. You can say, plot a graph of diameter of glass beakers against time against time and see if there is a relationship, and see if there is a relationship between them. Simple as that. Let's see the marking scheme as well. So you need a stopwatch, you need a ruler. We have written this, 1 mark secured. We will record the diameter of the beaker using the uh, vernier caliper or a measuring or a meter rule or a measuring tape. Measure the time taken to bring the water to its boiling point. Yes, we have done that using a stopwatch, and repeat the experiment for other beakers. Simple as that. What are your control variables? Mass and volume of the water. Simple. How will you draw the table? Diameter slash d, time slash t with the units. Either you can write diameter slash centimeter, or you can write d slash centimeter. No problems in both of them. Plot a graph of diameter against time. Either you can do this, or you can say compare the results in the table to see if the diameter of the beaker affects the time taken for the water to boil. Simple, you will get 6 on 6 if you write everything that was stated earlier. Let's try out another experiment. Let's try out another experiment. I think, yeah, we did this one, right? So let's try this one out. A student uses ice cubes to investigate the time taken for different masses of ice cube to melt when the ice cubes are placed in water. Okay. So a student is taking different masses of ice cube and is investigating the time taken for the ice cubes to melt. Perfect, perfect. Plan an experiment using ice cubes to investigate how the mass of ice cube affects the time taken for the ice to melt. Okay. We have to plan an experiment using ice cubes to investigate how the mass of the ice affects the time taken for the ice to melt. So, mass of ice is your independent variable. Time taken for ice is your dependent variable. Simple. What are your control variables? The volume of water, the initial temperature of water. Perfect. So you are given a top pan balance, supply of ice cubes, 250 cm cube of beaker, supply of cold water, and a stopwatch. Simple. You may also use other apparatus and materials that are usually available in a school laboratory. Plan In your plan, you should explain briefly how to do the investigation. If this word is written, explain briefly how to do the investigation. What are the 4 points that I have instructed you to write? Explain how you will measure the independent variable, explain how you will measure the dependent variable, and overview of the experiment, and repeat the experiment for different values of the independent variable. Let's write it down. You will say, you will say, measure, measure the mass of ice cube using a top pan balance, using a top pan balance. Simple. Then what will be your next step? Then what will be your next step? Measure a measure a known volume, known volume of water. Okay. Let's say 100 cm cube using a measuring cylinder, using a measuring cylinder, and add it to the beaker, and add it to the beaker. Simple. Then what will you say? Then what will you say? You can say pour the ice cube, drop the ice cube, or you can say place the ice cube inside the beaker. Start the stopwatch and start the stopwatch and start the stopwatch. Simple. Stop the timer or stop the stopwatch when the ice completely melts. When the ice cube completely melts. Simple. You have easily described how to measure the dependent variable, that is time, how to measure the independent variable, that is mass, and you have described how the experiment will be conducted. Just one point is left. Just one point is left. What is that point? You have to repeat the experiment for different values of independent variable. So you will say, repeat, repeat the experiment, repeat the experiment for different values of, for different masses of ice cube. Repeat the experiment for different masses of ice cubes. Simple. Here you have easily catered point number one. No ambiguity should be here. State the key variables to be kept constant. What are the key variables that are to be kept constant? We have already identified that. The control variables are the volume of water and the initial temperature of water. So you can say the control variables are the initial volume of water, initial volume, and temperature of water. Initial volume and initial temperature of water are your control variables. Second point also gets done. Now you have to draw a table. Let's draw a table. What is so difficult in this? What headings will you put? You will say mass of ice cube slash mass slash kg, and you will say in the second column time slash seconds. Third point also gets catered out. Let's move on to the last point. Explain how to use these readings to reach a conclusion. Again, you can write 2 points here, and one point is preferable, the second point is an additional point. What will you say? Compare the readings in the table, compare the readings in the table and see if mass of ice cubes affects the time taken for ice cubes to melt. Time taken for ice cubes to melt. Simple as that. And if you are really aiming for that A star, what further will you add here? What further will you add here? Plot a graph of mass of ice cubes, versus, or you can say against the time taken for ice cubes to melt. Simple as that, nothing complicated here. Let's see the marking scheme. You will get 1 mark for measuring the mass of ice cube. Perfect. Measuring the independent variable. You will get 1 mark for measuring the time. That is the dependent variable. You will get 1 mark for repeating the experiment for different masses. 3 marks here. You will get 1 mark for these control variables. You will get 1 mark for the table. Correct. And you will get 1 mark for comparing the readings and an impression mark, or you can say this leaves a good impression on the examiner. If you write that plot a graph of time against the mass of ice cubes, this leaves a really, really good impression. Let's practice another similar question. Okay, let's see this question which we were initially investigating. A student investigates the factor affecting the bend angle theta of a metal strip. The student places a thin straight metal strip on two supports and attaches a mass of weight W to the middle of the strip. Perfect. The metal strip bends as shown in figure 4.1. Perfect. Plan an experiment to investigate one variable affecting theta or the angle. Here I am taking W or weight as my independent variable. I will vary the weight and see how the theta varies. Perfect. What can be your control variables here? Your control variables can be what? Control variables can be this capital D, small d, and type of metal strip, all these types of things. So let's write down this answer as well. In your answer, you should explain briefly how to carry out the investigation. Again, you have to tell how will you measure the independent variable, how will you measure the dependent variable, including how will you measure the theta. Okay, perfect. That is your dependent variable. So let's write this first of all. Measure the mass the mass The mass of what? Are we given anything here? The student places it, okay, and attaches a mass to the, okay. So you will say measure the mass using a top pan balance, top pan balance, and multiply it with gravitational field strength, it with gravitational field strength, and multiply it with the gravitational field strength G to obtain weight, or W to obtain weight W. Simple as that. Measure the mass using a top pan balance and multiply it with the gravitational field strength to obtain the weight. Perfect. You have told how to measure the independent variable. Now, how will you measure the dependent variable? That is theta. Measure the corresponding, measure the corresponding bend angle theta using a large protractor. Using a large protractor. Simple as that. What's the last point that you have to tell here? Repeat the experiment for 5 to 6 values of W. Repeat the experiment for 5 to 6 values of W. Okay. The first point is catered out. Now, the second point, you have to tell the variables to control here. Which variables will you control here? The distance D, or you can say it like this. The distance D is actually what? The distance D is actually what? The distance between the two stands, you can say it like that. The distance between the two stands, the distance between the between the two stands, capital D, the type of metal strip, and the length of metal strip, and the length of metal strip should be kept constant. Should be kept constant. Simple as that. Second point gets catered out. What is your third point? Draw a table with column headings to show how to display your readings. Okay. How to draw a table now? You will say weight slash Newton on the first table and angle theta slash degree on the second heading. Simple as that. Angle theta slash degree. Simple. Oh, let's write it like this. Angle theta slash degree. Simple. Third point also gets catered. Explain how to use your readings to reach a conclusion. Very, very easy. How will you use the readings to reach the conclusion? Compare. Compare the results. Compare the results in the table. Compare the results in the table to see whether the weight affects theta or not. Simple. Then for the A star students, what will the A star students do? Plot a graph. Plot a graph of weight against theta. Simple as that. Plot a graph of weight against theta. Simple as that. Let's check the marking scheme. Use a protractor to measure theta. Vary this and measure D. Perfect. More than two measurements for W. Perfect. Keep D constant. Perfect. Use the same type of metal strip. Keep the length of the metal strip constant. Table with the chosen factors with the units. Plot a graph. Perfect. Compare the change in theta to the chosen factor. Simple, simple, simple. You will get 1 marks for each of them. Now, this marks the end of the design question key video. Almost the video has ended. There is one special type of question that I want to show you guys. There is one special type of question that I want to show you guys that neither includes a dependent variable nor an independent variable. What is that question? This is that question. This is examiner's one of the favorite question, and this question neither has any independent variable nor dependent variable. The terms that we need to describe here are completely different. So let's focus here. Okay, so let's see this question. A student has a converging lens and needs to determine its focal length. Perfect. Plan an experiment that will enable the students to measure an accurate value for the focal length of the lens. Perfect. The focal length of the lens can be calculated using this equation. Perfect. So the focal length of the lens can be calculated using this equation, where u is the distance between an object and the lens, and v is the distance between the focused image of the object and the lens. Perfect. Figure 4.1 shows some of the apparatus available. The complete apparatus is not available. One major thing is missing here. What is that? Screen. A screen is missing here. Perfect. The lamp is connected to a power supply and can be switched on and off. Write a plan for the experiment. In your plan, you should list any additional apparatus that you need. First of all, I can see that I don't have a screen and I don't have a meter rule. Perfect. Draw a diagram of the arrangement of the apparatus labeling U and V. Perfect. So let's draw a diagram of the apparatus labeling U and V. So first of all, we will draw this lamp. Okay, this is your lamp. And then you will draw this small little card like this. Obviously, if you have a scale, you can do a much better job than me. But you have to make sure that you label each and everything. You have to make sure that you label each and everything. Okay, this is your lens like this. Perfect. This is your lens holder. Perfect. Obviously, I know my drawing is really, really bad, so you guys don't need to laugh at it. This is a lens. This is your convert. This is your lens holder. This is your lens holder. Even I am laughing at my diagram. This is a lens holder. Perfect. And you will also have to draw a screen here. This carries a mark. Whatever additional apparatus you write in the first point, you have to draw it in the diagram as well. Also, you have to label U and V. What is U? U is the distance from the center of the object to the center of the lens. What is V? The distance from the center of the lens to the screen. This is V. Perfect. And lastly, if you are really aiming for that A star, what you can do? You can draw a meter rule here. You can draw a meter rule here. This shows that you will be using this meter rule in order to measure U and V. Simple as that. Nothing complicated here. Let's write down the answer as well. Let's draw it like this. Okay, let's write down the answer. List of additional apparatus needed. So what will you write? We will be requiring, we will be requiring, and or you can write it like this. A screen is required. A screen is required to form an image. Perfect. And a meter rule. And a meter rule is required to measure U and V. Simple as that. So your first point gets done, second point gets done. Briefly explain how to do the experiment. So what do we do in this experiment? Move the lens Move the lens with the lens holder, with the lens holder forwards and backwards, forwards and backwards until a sharp focused image is formed on the screen. Until a sharp focus image is formed on the screen. Then what will you do? Measure. Oh, let's put it in the next line. Measure, measure U and V. Simple as that. Measure U and V. Simple as that. We have done that. We have explained how to do the experiment. State the steps taken to form a sharp focused image. We have also done that. Also, you can write a precautionary measure here as well. Also, you can write a precautionary measure here as well. Conduct the experiment. Conduct the experiment in a dark room. Conduct the experiment in a dark room. Simple as that. What's your last step? Explain how to use your readings to determine if. Simple as that. Substitute. Substitute the values. Substitute the values of u and v in the equation of u and v. This is v. Sorry for my bad handwriting. Substitute the values of v, u and v in the equation. In which equation? F is equals to uv divided by u plus v, uv divided by u plus v, to obtain the value of f. Simple as that. Let's compare our answer with the marking scheme. Meter rule and a screen is required. Perfect. Arrangement showing u and v. Yeah, that's correct. Move the lens to form a sharp focus image. Measure u and v. Perfect. Carry out the experiment in a dark room. Perfect. Substitute values of u and v into the given equation to calculate f. Simple as that. Nothing complicated. This marks the end of the question 4 video. If you have any questions, you can ask in the chat. Also, this document, along with everything like these difficult questions document and these design notes, all of them are attached in the description below. You can access it from the Google Drive. Thank you for watching.